Okay, so they give you the point A minus 2, 5, the point B 3, 4, and the point C 1 minus 3. Is that right?
Yes, ma'am.
Right. Now they say determine, the first question is determine the length of, say for instance, AB, ne? Okay, now you look at the length formula, distance formula. It's that one, eh? So the formula is distance is equal to the square root of x2 minus x1. Now that 2 must be at the bottom. X2 minus x1 squared plus y2 minus y1 squared. Okay. So what I'm going to do is going to write down the A, which is minus 2, 5, and the B, which is 3, 4. Then I'm going to call the A x1 and y1, and I'm going to call the B x2 and y2. So now x2 is 3, x1 is negative 2, y2 is 4, and y1 is 5. So I substitute it with it.
Yes.
So that gives me the square root of, okay, it is 3 minus 2 squared. Do you agree? 3 minus 2, and then plus 4 minus 5 squared. So that actually gives me a plus, ne?
Yes, ma'am.
Because a minus and a minus a plus. So I have this, I have 5 squared plus 4 minus 5 is minus 1 squared. Then if I work it out, it gives you 25 plus 1, so it's the square root of 26. And now they say you must give the answers to one decimal, so square root of 26. Okay, what do you get?
And I get 5,09901,951.
Okay, square root of 26 into 1 gives you 5,1.
Yes, ma'am.
Do you agree?
Yes, ma'am.
Okay, that is the distance formula. The next question, they say the midpoint of, let's do now, BC. So now you write your B down. Your B is 3, 4, and your C is 1, negative 3. The midpoint formula, it's usually a big M when they talk about the midpoint, but when they talk about the gradient, it's a small m. Midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So now we call this one x1, y1, and we call this x2, y2. Okay, so now you substitute in the formula, so you have 3 plus 1, and you have 4 plus minus 3 divided by 2. So that's 4 divided by 2, and it is 4 minus 3 is 1 divided by 2. So that gives you the point 2 and a half. Clear?
Yes.
Okay, the next one, they want the gradient. Okay, let's do the gradient of AC. I just want to check something here. Perpendicular lines, midpoint. Okay, the gradient of AC. Now the formula for gradient is y2 minus y1 over x2 minus x1. Now I write down A is the point, -2, 5, and B is the point 3, 4. Now again, I call that x1, y1 and x2, y2. Now I substitute it. So then I have 4 minus 5 divided by 3 minus 2. Nee. 4 minus 5 is minus 1, and minus minus gives you a plus, so 3 plus 2 is 5. Now they say they want the equation of AC. Equation of AC. Do you agree?
Yes, ma'am.
So now you have the equation is usually y minus y1 is equal to m times x minus x1. Where did I get that? That formula.
Yes, ma'am.
You can use this formula, but that's longer. This one is actually like 4 steps.
Okay.
And you have less chance. Okay. Now again, I write that A is -2, 5, and that B is 3. No, I want
See them.
and I've worked out B there. I said AC, but I wrote 8B. Let me rather correct this. Ne? Let's just say then 8B. And then we also do here the equation of AB. Okay. So, and B is the point 3, 4. Now again, you see that is x1, y1, x2, y2. Okay. So we just, now we use the gradient here. We use the x value there, and we use the y value there. Do you see?
Yes, ma'am.
And now we substitute. We have y minus 5 equals minus 1/5 times x minus 2. So y minus 5 is equal to minus 1/5 times x plus 2. Now we multiply that in. So then we have y minus 5 equals minus 1/5 fifth x and then minus 2 fifths. Do you agree?
Yes, ma'am.
Now we take that one over because we have to have it in the correct form. So we have y minus 5 is equal to minus 1. No, sorry. I want this away. Why do I keep it? 1/5 x minus 2 over 5 plus 5. Eh?
Yes, ma'am.
So y is equal to minus 1 over 5x plus 4 and 3/5. If you don't know how to get the fractions, you can do it on your calculator.
Yes, ma'am.
Any questions so far?
No, ma'am, I'm fine now.
Understand it?
Yes, ma'am.
Sure.
Yes, ma'am.
Okay. Then we come to number 5. Okay, the equation. Now we determine the inclination of the line. Inclination. And inclination have to do with gradient. So with other words, m, and with the tan function, with the inverse of the tan function. So you're going to use shift tan, eh? And inclination is an angle that you have to find.
Yes, ma'am.
So, okay. So let's do it for the line BC. So B is the point 34 and C is the point 1, negative 3. So now we must get the gradient. The tan of theta is equal to the gradient. The gradient is y2 minus y1 over x2 minus x1. See?
Yes, ma'am.
So now this is going to be x1, y1. That's going to be x2, y2. Alright. So, okay, let me carry on. So this means that tan of theta is now, and the gradient is minus 3 minus 4 over 1 minus 3. So that gives you minus 7 over negative 2, and that is 7 over 2. So now you have that tan theta is equal to 7 over 2.
Yes, ma'am.
Now you use your shift function. You say shift tan, then it will do this, and then you say 7 divided by 2, close the bracket, equals. So shift tan 7 divided by 2, close the bracket, equals. That is 74,1 degrees. So with other words, theta is 74,1 degrees, and therefore the inclination is equal to 74,1 degrees.
Yes, ma'am.
Okay. You still happy?
Yes, ma'am. I am.
Sure.
Yes, ma'am.
How happy are you? So or so?
I don't think so.
Okay. Now we come also to the next one. Collinear points. Collinear points. Ne? That means points on one line. So with other words, if you test if something is a point on one line, you have to do this. So now you have the lines P, which is -2 and -6. You have the line Q, the point Q, that is 2 and -4, and you have R, that is 4 and -3. So you test what is the gradient of this 2, and you test what's the gradient of this 2. So now you say the gradient of PQ is y2 minus y1 over x2 minus x1. So in this case, that's x2 and y2 and x1 and y1. Okay, now y2 minus y1 is minus 4 minus 6. And that is 2 minus 2. Do you see? So you have minus 4 plus 6 is 2, and 2 plus 2 is 4, and that is a half. Now you're going to do the gradient of QR. So the gradient of QR is minus 3 minus 4, see?
Yes, ma'am.
Over 4 minus 2. So that's minus 3 plus 4 give you 1, and 4 minus 2 is 2. Now you see the gradient of PQ is equal to the gradient of QR. Therefore, the lines are collinear. Agree?
Yes, ma'am.
Okay. I want to save this now and send it, and then we do